Explain the different design principles used in enterprise network design, such as Tier 2 and Tier 3. Let's see what is this about. What this design principle tells you is, for instance, if you have a building, locate your distribution switches at the MDF and your access switches at least one per floor, and connect your access switches with redundant links to your distribution switches. So you will end up having these triangle shaped topologies. So if you see this triangle shaped topology in your network, you are doing it right. Don't do it otherwise. Don't start connecting switches to each other as you please. Follow this topology design. So another way to draw this building design is just a redraw of the same topology, and you can end up having these two cases, tier 3 or tier 2. When you have a tier 3 topology, you have a core layer, a distribution layer, and an access layer. The core layer is pure IP. You have routing protocols running here. And the purpose of the core layer is to connect your user networks to other networks, like the internet, or your server networks, like your data center. So, and the distribution layer is the border between the core layer and the access layer. So the distribution layer will be running routing protocols inside the core layer, and will be running spanning tree protocol into the access layer. So at the distribution layer, you will also be advertising your end user's network into the core, and you will probably be configuring the first hop redundancy protocol here at the distribution, such as BRRP, HSRP, or GLVP. So the downside of this design is that you will have to run a spanning tree protocol. The access layer is the point where you will be connecting your end users and your end user devices. So you can also connect wireless IP that will extend the access layer into the wireless realm. Your access layer is also considered to be the quality of service trust boundary, or your quality of experience layer. If you don't have a network that is that large, you can choose to use the tier 2 topology, where the core and the distribution are collapsed together. This is also known as the collapsed core and distribution topology. In these two examples, the access switches are running layer 2. So that is the reason you will need a spanning tree protocol here. But what happens if you can expend more money and get multi-layer switches in your access layer? You can run IP in your access layer and have a pure IP environment. If you have a pure IP environment, you will get rid of a spanning tree protocol, which is a good thing. The other option you have is perhaps using a virtual switching system, or stacking technology. With these technologies, separate switches are connected to each other in such a way that they believe they are a single big switch. So if you use these technologies, you can have a redundancy between your distribution and your access layer using ether channels. So ether channels will provide you with redundancy and still without the need of a spanning tree protocol, which is also a good thing. So final note here, these topologies were thought on moving traffic between north and south. That means between your users and the internet, or between your data center and your end users. It was not created having in mind moving traffic between west and east. And there is another topology that is very good at that, which is known as the spine and leaf topology, that is used in data centers, where you have a spine layer made of many switches. So they are so many that you avoid overwhelming any one of them or creating bottlenecks and distributing the load among them. And you have a leaf layer where you will connect your servers. So there is a mesh, a full mesh of cabling between the leaf layer and the spine layer. And the leaf layer can run IP, so you can run a pure IP environment, and you can use newer protocols like VXLAN and other cool stuff. So you can move traffic between north and south and between west and east quite efficiently. That's it.